So are you guys able to hear me? Are you able to see my screen? Are you able to see my screen now? Hello. His voice is okay now? Yeah, okay. Today we are going to discuss the week 4 solve with us. Like today there are we discuss 6 questions. We'll discuss 6 questions which deal with majority of the portion, which covers majority of the week 4 contents. I think everyone have gone through the week 4 contents. Yeah, we will discuss some questions at the end. Someone have wrote question number 4.5, question number 3. Don't worry, we will discuss some questions if there is some time left. You're unable to see the questions. Everyone able to see the questions? Yeah. Everyone able to hear now? Yeah. Sorry for the delay. There is some problem with the internet connection. Yeah. We'll move on to the first question. Like, by dividing a polynomial p of x with another polynomial q of x, we get h of x as the coefficient and r of x as a remainder. So we can say that yeah, you can say that p of x by remainder theorem, you can say that p of x is equal to q of x into h of x plus r of x, where r of x is remainder and q of x is dividend and h of x is coefficient and q of x is divisor. Hello? Yeah, no need to join the desk, okay? Hello. Just this is the explanation. I will explain these questions. Just try to solve this question and tell me the answer. I will give you 5 minutes. Hello. Everyone try to solve this. Hello, answer this question. Why C and why D? Hello? Is it a y? Can anyone? Hello? Can anyone type YA YD explanation? Can anyone type the explanation like in the chart? Okay, someone said that. Okay. Look, someone said I am writing all these points. Someone said degree of remainder is always less than divisor. Okay, this is a good point. Like it is correct. But Hello. Thank you. Just thank you for your patience. Just wait, I will share my screen. Well, are you able to hear me? Yeah, bro, I didn't share the screen. Don't worry. Look, here the minimum degree. They ask the minimum degree. Does my question is, does every division has multiplication? Sorry, has remainder. This is my question. Look, there are two cases. There, there might be a remainder or no remainder. Yeah, no remainder. If at all there is no remainder, that means remainder is 0. For suppose we will take the uh, remainder case, which is this case. The remainder, look, when we will get the remainder, for suppose we are dividing x square plus 3x plus 4, we are dividing with x minus 1. Then let us simply divide this x. x square minus x minus plus 4x plus 4. 4x minus 4 x plus 8. Look, remainder is 8, which is a constant value. But this is not the case. This is not the case with every division. We have to look. Why we stopped at 8? Because why we stop our division at 8? Because the 8 is remainder is remainder degree. Sorry, degree of the remainder. Because degree of the remainder is less than the degree of divisor. So we stop the division. So here, but the question is, what is the minimum degree? What is the minimum degree? So minimum degree possible is 0. Why 0? If at all the remainder is constant, degree of the constant is 0. Since degree of constant is 0. Agree? Everyone agree with this? Yeah. Anyone has some doubt? Like, yeah, the question is, look, someone have raised a query, like minimum degree of the remainder. Yeah, they asked about the minimum degree of the remainder. It can be 0, not always like the minimum degree is like degree of q of x minus 1. Hello? I'm not getting this question. Is degree of remainder because Surya is degree of remainder greater than degree of remainder? What is that? Like, I think there is some mistake in your question, I think. And then we will move on to the next question. Next question is the maximum degree of the remainder. Can anyone answer this? What is the maximum degree of the remainder? Just think twice. Actually, answer is there. Anyone explain why? Why D? Explain why D. Yeah, Drishti. Yeah, answered correctly because look, I already explained this. Why we stopped division at 8? Because degree of the remainder is less than the degree of the divisor. That is the reason why we stopped the division. So here in the question, what they asked, the maximum degree of the R of x is, hello? Okay, okay, I got that doubt. Okay, are you everyone clear with this? Hello. Yeah, because the answer lies here. And then coming to the, we are moving to the second question. Like I'm giving you like 6 minutes. Try to solve this. So we will solve this question. Most of your answers are lie between C and D. I will explain you. I mean, like how to solve these types of question. Like you find a big equation like this, like 1 by 1. Minus x minus 10 whole square, x minus 8 whole square, x minus 6, x minus 4, x minus 2, x square into x plus 9. Look, you have to draw it first step. Step 1, draw a rough graph. Okay, how will you draw the rough graph? Rough graph. Like, look, you learned about already about end behavior of the endpoint behavior. Endpoint behavior of the polynomial. We'll use that. Look here, first we have to see the roots, like what are the number of roots. Look, we write roots. And what are the, how many, I mean like multiplicity. Like what multiplicity? How many times the root exists? If at all, look, and roots and multiplicity. For suppose we will take this example, like here minus x minus 10 whole square, which is minus x plus 10 whole square. So what are the roots? Like minus 10. Minus 10 is the root. And how many times the root repeated? 2 times. Multiplicity is 2. Hello? Is my voice clear? Hello? Yeah. Did you understand about multiplicity? Here minus 10. Why minus 10 is root? Look, minus x, listen this carefully. This is the tricky part of the question. Look, minus x minus 10 whole square. Look, take minus common. Minus plus 10 whole square. Minus 1 square is 1 and x plus 10 whole square. If we equal this to 0, what will happen? X plus 10 into x plus 10 equal to 0. So x equal to minus 10, minus 10. Agree? Yeah. So the multiplicity is 2. And coming to the next, what is the next root? 8. I will write the roots here. Look here, it is plus 10 and it is 8. Root is 8. And here root is 6 and root is 4 and root is 2, 0 and minus 9. Look, we are writing the same with multiplicity. 8. What is the multiplicity of root 8? Yeah, it is 2. And what is the multiplicity of 6? Root 6? 1. What is the multiplicity of root 4? 1. And 2 is also 1. And 0 is 2. And minus 9 is 1. Okay. Now can anyone tell what is the end behavior of this curve? What is the end behavior of this polynomial? I just need only end, like what if x tends to infinity and what if x tends to minus infinity. I only need this. No, leave about the up. I mean, like upward or downward. If x tends to infinity, what will I get? And if x tends to minus infinity, what will I get? Okay, of x tends to infinity, you'll get infinity only. Whether it is plus infinity or minus infinity, that is my question. So to answer this question like very easily, like in lectures, Sir said that to remember some I mean like some things like if a is less than 0, but to get it very easily, like see this example, like see this, the given is minus 1 by some 1 lakh 2 minus x minus 10 whole square, x minus 8, x minus 6, x minus 4, x minus 2, x square, x plus 9. Just substitute plus infinity and minus infinity. Look, if you substitute plus infinity, look, as there is minus symbol, you will get minus infinity. And if you substitute minus infinity, you will get plus infinity. Agree? Is it clear? I think it is confusing. Let us see. Minus 1 by 1 lakh. Look, this can be written as x plus 10 whole square minus x minus 8, x minus 6, x minus 4, x minus 2, x square, x plus 9. Look, if you substitute, all this becomes plus infinity. If you substitute x tends to infinity, as x tends to infinity, all this become infinity. But you have minus symbol, so it will become minus infinity. Agree? Hello? Hello? Yeah. And alternately, if x tends to minus infinity, it will become minus into minus infinity. That is plus infinity. Agree? Hello? Yeah, I'm seeing the message. Yeah, I'm seeing the message. Don't worry. I'm waiting for your message. Okay? So you got the end behaviors of the now you got the end behaviors. can say that yes, this is x tends to plus infinity and minus infinity. You can draw the end like it will be like this sum. It goes down and it as it tends to minus infinity, it goes to infinity. It goes up. Agree? And then now we need to analyze the roots now. Here the roots are like minus 10, 8. Roots are minus 10, 8 with multiplicity. Minus 10, 8, 6, 4, 2, 0, minus 9, 2, 1, 1, 4, sorry, 1, 1, 1, 2, and 1. Yeah, I will come to that. How will you check order? Don't worry. Okay, we'll discuss it. Don't worry. And then coming to this, now draw a number line. So please draw a number line and plot all the roots. 0, highest root is minus 10, 8, 6, 4, 2, minus 9. Look, we already know the end behavior. Look, it comes from minus infinity. It comes from infinity. I mean, like it goes to minus at at x equal to minus infinity. In this way, it is minus infinity. This way, it is plus infinity. As we already calculated the end behavior. If x tends to infinity, then y become minus infinity. And if x tends to minus infinity, y become infinity. I already discussed it here. Don't worry. Okay. So look, in this side, x tends to minus infinity. So it should start from infinity, like this, y equal to infinity. And then it will go and it will touch the x equal to minus 10. Look, listen carefully. Hello, are you able to hear me? Hello. Look, if you have to start from this side. Why this side? Because as x tends to minus infinity, y goes to infinity. So from top it will start. It will go like this, like this, like this. Look, now we got a doubt here. It will go till 10. Look, here we will get doubt. Like everyone has this doubt whether it will go down or go up. Does everyone have this doubt? Hello. Look, to clear, look, everyone has this doubt, but look, the use of multiplicity comes now. Like here, the multiplicity is 2, even multiplicity. What does even multiplicity say is that, like, just take a normal example, like some y equal to x square or x equal to y square, anything is okay. You will get a graph like this. So whenever there is a square, It touches and bounces, I mean like goes up again. Hello. Or else it will be like this if it is minus x. Like, or else it will be like this somewhere. It will touches and it will cross, I mean like it will change the direction. Hello. Clear? Okay, some in, I mean like the other way of saying it is like it doesn't cross x-axis. Even multiplicity doesn't cross x-axis. Look, now you got a clear picture which side to go. Like you go down. And then the next route, look, the next route we have to go is like minus 9 because after that, after minus 10, we'll get minus 9 in the number line. So the next thing is to go to the minus 9. Look, now just connect minus 10 and minus 9 like this. Go to minus 9. Look, here the multiplicity of the minus 9, root minus 9 is odd. So it crosses x-axis. Hello? Are you able to understand? Yeah. Now it crosses the x-axis and it will touches the next root. Like it will goes till the next root. What is the next root? 0 in the number line, like it is 0. Now look, 0 multiplicity of 0 is even. So it doesn't cross the x-axis, just touches and goes down again, like just touches. Just touches. And the next root in the number line is 2. And it, again it will go up. The multiplicity of 2, I mean like multiplicity of root 2 is 1. And all other multiplicities are 1. So it will go like this, like a wave. And it will go till minus infinity. Hello? Everyone understood this? Hello? Do I need to explain again? Clear? Yeah, I will try to skim one. I mean, like, just I will try to give a brief, like, if at all, look, the two main things that we should consider while drawing a rough graph are drawing rough graph. Like, there are only two things to consider, like, two important things. One, roots and multiplicity. How many times does root repeat? Here we got root minus 10, it repeated 2 times. If multiplicity is even, look, again, this even. If it is even, what does it mean? Curve doesn't cross x-axis. Is odd, curve crosses x-axis. Clear? Hello? Hello, clear for everyone? Hello? Yeah. Someone said we cannot draw from right to left. No, it is not like that. First, you have to see the uh, end, endpoint behaviors. Look, look. The reason for this endpoint behavior is like, look, if you got this endpoint behavior wrong, like for suppose you didn't consider this endpoint behavior, then you know how your graph would look like. I'm drawing green. Look, just if you reverse it, the endpoint will. If you are unable to see this, just if you reverse the graph, I mean, if you reverse the endpoint behavior, everything will change. It will be like this. It will be like this. Everything will change. Hello? Bro, did you understand? Are you able to understand? Yeah. The important thing is this and behavior. You have to be very careful while like checking the end behavior, because if end behavior goes wrong, your curve will be reversed. Like it will be like a mirror image. Clear for everyone? Someone said, Ankit Kumar said, I have some doubt. Like you can ask the doubt. Sorry, I mean I can't unmute. Like just you can type. Oh, it's like okay. Zero has even multiplicity. Why it goes down? Like okay. I want to explain this. Look, just wait for a moment. I'm reading all these things. Look, even multiplicity means even multiplicity means it won't cross x-axis. Look, for suppose in the above graph, it will goes from down to here like top. Look, it just touches and just it goes again down because it can't go up. If it goes up, it is like a crossing the x-axis. So this sometimes this can also be changed direction change. Direction change. Hello. Yeah, it will be available in YouTube. Someone has already can you please explain this? Yeah, again, just right. Look. Listen this carefully. X minus 2 whole square. This is example. X minus 2 whole square plus x plus 3 into x minus 4 whole square, x minus 6. Let these be roots. This be a equation like polynomial p of x. So to draw the rough graph of this, just what are the end behavior? Like first consider end behavior. If x tends to infinity, then it is plus infinity. If x tends to minus infinity, it is minus infinity. Agree? Why? Look here, minus infinity whole square, minus infinity, minus infinity whole square, minus infinity. It is like, hello, sorry, I have done a small mistake. If x tends to infinity, then y goes to infinity. If x tends to minus infinity, just check. Minus infinity whole square into minus infinity whole square minus infinity. So what does y tends to infinity? Agree? Hello? Hello, agree with this? Agree with this and behavior. And then just draw graph with roots, like just plot all the roots. 0 is not a root, like 2, minus 3, 4, 6. These are the roots. Now listen this very carefully. Like, look, it starts from like x. Let us start from x equal to infinity, then y equal to infinity. Then it will be like this in the top. It will come down like this, and at x equal to 6. There is only one root, like multiplicity. Look, I will write the multiplicities. 2. Multiplicity of 2 is 2, and minus 3 is 1, 4 is 2, and 6 is 1. Look, the multiplicity of 6 is only 1, like odd multiplicity. So what happens is that it crosses the x-axis like this. And then what happens is that it will goes to 4 like this. Like it again goes to 4. Now there is an even multiplicity. 4 has a multiplicity of 2. Just touches the x-axis like this. It will change the direction. And it will go like this. It will hit the 2. As 2 also has the even multiplicity, again it will hit, and it won't cross the x-axis, but it changes the direction, and it will directly, and it will goes to the infinity plus infinity. Agree? Hello? Hello? Are you able? I mean, is it clear for everyone? Yeah. Then we'll move on to the next question. Like, okay. I need to explain one more thing. Like in this, okay, what happens if the multiplicity is 3? Look, for suppose the same, we will take the same x minus 3 whole cube, x plus 4 whole square, x minus 1. I want the graph of this. Look, here multiplicity, root multiplicity 3, 3, minus 4, 2, and 1, 1. Look, and behavior. And behavior. X tends to infinity, then y tends to infinity. If x tends to minus infinity, y tends to infinity. Y minus infinity whole cube, infinity square, infinity. Hello? So here 0, 1, 3, minus 4. Look, we will start from this side. X tends to infinity, this person. Look carefully. 2, 3 has 3. I mean, like multiplicity is 3. So it will change the, I mean, it will cross the x-axis like this. It will again, it will cross the x-axis like this. It will again go to 1. As the multiplicity is 1, it crosses the x-axis. Go in the minus 4. As the minus 4 has multiplicity 2, it won't cross the x-axis. It will go up till infinity. Here, look, and behavior, look, this is like, this is general value. Just put minus infinity whole cube. look, minus stays here, minus infinity, and then coming to this infinity, it will become infinity square. And then this is like layman approach, like it is not a mathematical approach. Hello, hello, hello. Are you able to hear me? Look, it is like normal, like uh, just did you watch? I mean, like you guys have watched the lectures. They have presented in a good way. Like if I mean, like if the leading coefficient, I mean, like leading power, like degree of the polynomial is odd, they have presented in that approach. That is the perfect approach. Are you getting the point? I want to just I want to explain this because you can do using this also, this method also. That's it. That is the main thing. Now let us move to the third question. I can't guarantee you that, but this summary lecture, this is not a summary lecture. This is like I am summarizing because you guys are not clear in these topics. Because that is the reason why I am summarizing. Like this is just a, I mean, like I will, these questions might cover 90% of the syllabus. I mean, of week 4, these questions. The later 10%, the 10% might be missed, but it will cover 90%. I'm sure that it will cover 90%. Okay? And then coming to the next question. Like, are you able to see the question? No. Yeah. So, I mean, like, we have to take something common to solve a cubic equation. There are other methods which is like out. I mean, like this. It is not. I mean, it is not related to this. Like this max one course. I will just give you a brief like how it will be done. Okay, but not a complete thing. Like clear 8 to 7. Hello. Those are known as numerical methods. Like, actually, what happens if you can't take look for suppose uh, these things every time you can take common. I mean, like, but if you need perfect root for some equations, all the roots will be in decimal points. To approach these roots, we use something known as numerical methods. I will just give you a brief how they are derived, like how they, I mean, like how there is something, there is a one branch related to the max one. Just I will try to give a brief on that. Are you guys doing the question 3? Hello, are you able to hear me? Yeah, I will try to give you a hint, like given sum of roots, just try to use that. Look, I'm giving you a hint. Look, given m, n, p are roots. That means m cube plus 5m minus 10 equal to 0. N cube plus 5m minus 10 equal to 0. And p cube plus 5p minus 10 equal to 0. Use these three. Hello. Hello, guys. Just use these three equations and try to solve. I need more answers. Come on, guys. Do this one. Like very simple. Okay, I'm explaining this. Just consider add all these things. M cube plus n cube plus p cube. Plus take 5 common. I'm taking 5 common. M plus n plus p minus 10 minus 10 minus 10 equal to 0. M cube plus n cube plus p cube. We don't know this value. Look carefully, we don't know this value. We don't know this. We don't know this. M plus n plus p 5 and n plus minus 30 equal to 0. But we have the equation like x cube plus x minus 10 equal to 0. This is a cubic equation. But we don't know m. What are the roots? M, n, p are roots. So sum of roots equal to m plus n plus p equal to, you can write a formula minus b by a. This is a formula where b is 0 by a 1. 0. Agree? Hello? Hello? Hello guys, are you able to hear me? Yeah. And then what is happening here is like, we'll substitute here m cube plus n cube plus p cube plus 0 minus 30 equal to 0. M cube n cube plus p cube equal to 30. Agree? Hello? Yeah. Can we move on to the next question? Someone in chart, someone used another approach. A cube plus b cube plus c cube equal to 3ab. Like if a plus b plus c equal to 0, you can do that approach also, but it is not like, if it is a quadratic equation, I mean like, if the power of the equation is x power 4, like in the order of 4, then you can't do that. Can we move on? Can I move to the next question? Okay. Okay, you can take screenshot, like just. I move to the next question. Okay, I'm giving you 2 minutes time. Like I'm just giving you 2 minutes because. Okay, just take 5 minutes. Okay, how did you approach n equal to -2? V Tirunakasuru, how did you approach? I mean like, what is your approach? N equal to -2. You answered really quick. Yeah, sum of roots. I mean like, sum of roots formula work for all the polynomials, and the product of, I mean like, it will work for all the polynomials, not the other formulas like product of roots and these. But some of the roots will work for all the polynomials, irrespective of the degree. Okay, you substituted the, I mean like, 1 and 2. You have gone in that way. Okay. Do you know what is the actual approach? Yeah, Pushendra Singh. Yeah, that is the look. What happens if someone give you the polynomial equation and they ask the best fit for polynomial? Search for the 0, because it always gives you the, I mean like, constant. Hello? No. Actually, you have to use like this yi minus xi minus c whole square. But whenever you find 0, then x equal to 0, then you can take some chance because, hello? Are you able to hear me? Look, I will tell you how to approach. How to approach. Look, in this question, you can clearly see there is 0. This is like not every time don't follow this, but most of the cases it works like x equal to 0, then it is minus 2. That means f of 0 equal to minus 2. That means x cube plus 3x square plus n equal to f of x. F of 0 equal to minus 2 equal to 0 cube plus 3 into 0 square plus n. N equal to minus 2. The next thing you have to do is like check by substituting all these other values, like all these other values. What is the f of x now? F of x equal to x cube plus 3x square plus n equal to x cube plus 3x square minus 2 f of x. Now substitute f minus 1, f of minus 1 that equal to minus 1 whole cube plus 3 into minus 1 whole square minus 2. Minus 1 plus 3 minus 2 that equal to 0. Hello guys, are you getting the point? Hello? Yeah. Look, now you can. What is the other approach like? What is the other approach? Other approach. Look, in this you have take one point like this point, not this, like this point, like y equal to 0 that equal to x cube plus 3x square plus n equal to 0. Now they have clearly given at x equal to minus 1 whole cube plus 3 into minus plus n equal to 0. 1 minus 1 plus 3 plus n equal to same n equal to minus 2. You got n equal to minus 2. Hello? Are you able to understand this? Now we'll go to the actual approach. Actual approach. This is the correct way. Let's take x and y values. X equal to minus 3, minus 2, minus 1, 0. Then y equal to minus 2, 2, 0, minus 2. We will do y minus x cube plus 3x square plus n whole square. This is sum of squares error SSC. Okay, you don't know what is SSC. Okay, you need this explanation y minus x cube minus 3x square plus n. Ajhan Pari. Hello? Ajhan Pari. I mean, what you need like in SSC? Okay, you need how did you get this formula like y minus x cube? Okay, this is carefully. Look, y. Look, there are Suppose this equation x cube plus 3x square plus n. This equation yields one y value. But we have y value in data. Y value in data. Clear till now? Hello. Now y value in data. Look, this y value obtained by equation and the y value in data, they might be different. They might be different. So error equal to y obtained minus y data. But we don't, we don't like this error because it can be positive or negative. If we add error, it will become like, sometimes what happens is that error might become 0. So what we'll do is like we will square this, square of the error equal to y obtained minus y data whole square. What we will do, we will add all this sum of squares of error. We will add for every point y obtained minus y data whole square for every point, for point 1 to number of points. Clear till now? Here, now listen this very carefully. Here, this y obtained is this thing, which x cube plus 3x square plus n, and y data is what you have in the data. Clear? Ajhan Fari. Yeah. Thank you. And then we got this formula finally. I need to draw this again. X, y minus x cube plus 3x square plus n. Just repeat, minus 3 minus 2 minus 2 2 minus 1 0 0 minus 2. Hello, clear till now? Hello guys. Yeah, you can take this like y. What is the y value here? I will do for one thing like minus 3, minus 2. Y is minus 2 here. Minus 2 minus x cube, like minus 3 whole cube plus 3 into 3 square plus n whole square. Look, I am extending this. I am only extending this. Minus 2 minus 27 plus 27 plus n whole square. Minus 2 minus n square. Hello? Minus 2 minus 0 plus n whole square. Minus 2 minus n whole square. Agree? Hello? And then what is the in question, just see the question, like what they ask in the question. SSC is minimum. What is the minimum possible value of SSC? It is 0. Just equal to 0. Or you can do the same thing for all these three. 2 minus all these three. Are you understanding the point? Yeah, you can ask the doubt. Dipakshi Kashyap. But this table is nothing like Ankit Kumar. Look, this table is like I explained you what is sum of squares of error. Just follow this. Like, listen this carefully. Y. What is the y value? -2. This is the like actual y value. But using the equation, what is the equation? This x cube plus 3x square plus n. Use this equation. What is the x value? -3. -3 whole cube plus 3 into -3 whole square plus n. Hello? Yeah. And then finally, you'll get this. Clear till now? Can I move to the next question? From Juha Sumit Kumar. Sumit Kumar, what value are we doing sum of squares of error? What does that mean? Yeah, you can ask the doubt. Kashyap, Dipakshi Kashyap. Okay, I'm moving to the next question. So how to take common when we have minus sign in leading question? Yeah, just remove minus sign and change all the signs. You can do that. Like using this example, I will explain. Don't worry. Like I'm moving to the next question. Are you able to see the question? This is the final question, most probably. Yeah, this is the final question. Dipakshi Kashyap. Actually, then the thing is like you are missing something. Just check the cubes. Minus one cube is one. Just a cubes under squares. Just do it clearly. Like I think you have done some mistake there. Like yes, someone said what? Just just answer, guys. This is the last question. You should have some Josh. You'll be free after 10 minutes. Yeah, you can take the screenshot. Okay, take the screenshot. Like Yeah, I'm displaying the question. Okay, I will give you the hint. Like, you have to find the intersection between f of x and g of x. Just I give you a hint. Like, you have to find the intersection point. No, read the question twice. Like, the Ministry of Road Transport and Highways want to connect three aspirational districts with two roads, R1 or R2. Two roads are connected if they intersect. The shape of the two roads are given by two polynomials. Look, the two roads are only connected if they intersect. That means, how did you find in straight lines? How did you find the intersection point between two lines? Yeah, equate f of x and g of x. Look, listen this question very carefully. Hello, are you able to hear me? Yeah. The Ministry of Road Transport and Highways want to connect three districts, like district 1, 2, and 3. Just for like visualizing, just I have drawn something. Two roads are connected if they intersect, like using two roads. Like, this might be first road, this might be second road. Okay, R1 and R2. Clear till now? I'll put R2 here from. Then, given that f of x is equal to x minus 11 whole square, x minus 13 whole square, and g of x, it represents the R1 root. It represents the R2 root. X minus 11 minus x minus 11, x minus 13. We know that they said that two roots are connected if they intersect. Given that R1 and R2 are connected, so there must be an intersection point. F of x equal to g of x, that equal to x minus 11 whole square, x minus 13 whole square equal to minus x minus 11, x minus 13. Clear? Look, square and x minus 11 get cancelled. Square and x minus 11 into x minus 13 equal to 0. X equal to 11, x equal to 13. What does it mean? Okay, sorry, sir. I have done just now. Hello? X minus 11, x minus 13 equal to minus 1. Because there is minus symbol. Hello? Not 0. Hello? Are you able to listen? Hello? Yeah. I have done some mistake. Sorry. Equal to minus 1. X minus 11 into x minus 13 plus 1 equal to 0. This is the equation. So, x minus. So, it's perpendicular answer. Stop. I'm solving the question. Hello. Just wait for 2 minutes. Leave about perpendicularity these things. Okay. F of x equal this, like f of x equal to x minus 11 whole square, x minus 13 whole square equal to g of x is minus x minus 11 to x minus 13. X minus 11 into x minus 13. Then plus x plus 11 into x minus 13 equal to 0. X minus 11 into x minus 13. We will take this common and then we will get x minus 11 into x minus 13 plus 1 equal to 0. So you got roots like x minus 11 into x minus 13 equal to 0 and x minus 11 into x minus 13 plus 1 equal to 0. So x equal to 11, x equal to 13. So here we need to solve this. Like how will you solve this? Hello? Okay, how will you solve that? X equal to 2. Okay, leave that. Look, one thing we can look before expanding all this and making a quadratic equation, just check. Look, there is 12 and there is 13 and there is 1 like. So let us take 12, substitute 12 like 12 minus 11 into 12 minus 13. 1 into minus 1. Minus 1 plus 1. So it is 0. So x equal to 12 is the other root. But the actual process is this is not possible every time. The actual process is expand like x square minus 11x minus 13x plus 143 plus 1 equal to 0. X square minus 24x plus 144 equal to 0, which is x minus 12 whole square equal to 0. X equal to 12 comma 12. Hello, are you able to get this? Yeah. So what are the roots or intersection points? 11, 12, 13. These are the intersection points between R1 and R2, two roots. But what they asked in the question, check that. What will be the x coordinate of the third? Like, I didn't put the question. What will be x coordinate of third district? But the question is, what will be the x coordinate of third district given that first two districts are at x intercept of f of x and g of x. 11 and 13. Look this side. Hello. A1155. Look. This is the question. What will be the x coordinate of third district given that first two districts are at x intercept of f of x and g of x. Look. District 1. What is x intercept of f of x? Minus x minus 11 whole square, x minus 13 whole square. What are the x intercepts? 11 comma 13. Agree? Hello? Hello, are you able to hear me? Hello? Yeah. The x intercept of f of x is 11 comma 13. And for district 2, x intercept of g of x minus x minus 11 x minus 13. Same 11 comma 13. Look, that means listen this carefully. Both like 11, 13. Hello. Hello, are you able to hear me? Yeah, listen this really carefully. Like district 1 may lie at 11 or 13, and district 2 also lie on 11 or 13. Hello. So if your road is connecting between district 1 and district 2 to district 3, it must satisfy this intersection. So where is the intersection point between two curves? Like, hello, are you able to understand this? Listen this carefully. Like, if at all, look, the 2 has the x-intercept at 11, 13. That means the district 1 might lie between at 11 and district 2, then district 2 lies at 13. If district 1 lies at 13, then district 2 lies at 11. If these two curves are intersecting, like, then the only possible intersection point other than 11 and 13 are 12. So, the only possible thing is 12. Okay, someone said once more. Look, here, first district might lie at 11 or 13 x coordinate. Second district also lie at 11 or 13. So, if first district is at 11 coordinate, then second district is at 13th x coordinate. But it may go reverse also. If first district is at 13, then second district is at 11. But remember this, given that R1 and R2 are intersecting, they too must intersect. The only possible thing is that what are the intersection point? 11, 12, 13 are the intersection point. So, look, if the road goes 11, 13, or if the road goes like this, 11, 13, the what is the other possible thing intersection point? 12. 12 is the intersection point. Hello, are you getting this? Hello, are you able to understand this? Hello. Okay. Just I will try to explain again. Just for suppose, look, uh, okay, Diksha Sharma, just try to understand this little point. Like 11 and 13 are the x coordinates of district 1 and district 2. What is happening here is that district 1 and 2 must be connected by a road passing through district 3. So the other possible point is like only 12. Other than these two, the both intersect at common point 12. The both the roads R1 and R2 intersect at 12. That is the reason why you're struggling to imagine. Just stop. I'll make it easy. Just one. For suppose this is the curve, and this black one is like this. Hello, agree? They gave that one. It must pass through this third, but this is not our graph. Like this is not the graph. Just if this is R1 and this is R2, they both are intersecting in such a way that they are connecting three cities. Look, what are the possible cities? City 1, this is the city 2, and this is the city 3. Agree? Yeah, intersection points can be decimal. Intersection point can be decimal. Leave about that. But in our case, it is not decimal. Here, what did they give is that R1 and R2. Okay, I will draw the graphs for these things. Like f of x, we will get f of x equal to x minus 11 whole square, x minus 13 whole square. G of x is equal to minus x minus 11, x minus 13. 11, 13. Look, endpoint behavior. Endpoint behavior is like x tends to infinity, then y tends to infinity, x tends to minus infinity, then y tends to infinity. Look, this is like even root. So it will go like this. Again, even root. It will go like this. Clear? This is R1. Hello. And then coming to the other thing, like x minus 11 minus x minus 13. So here, endpoint behavior. Endpoint EPB means endpoint behavior. It is like x tends to infinity, then y tends to minus infinity. X tends to minus infinity, y tends to infinity. So as x tends to infinity, it tends to minus infinity. So it will go from down 13 and then it will go minus infinity. Then it will go x tends to minus infinity, y tends to minus infinity. Just then it will go like this. Hello, clear this graph. Hello. But what is happening is that if you see clearly, these two intersect here, 12, 12 comma somewhere like. So in the question they asked what is the district third. This is the district third. Hello, clear? Are you able to visualize this graph? Clear for everyone? Yeah. Yeah. I think this is the end of the session. Actually, but these questions cover, I mean, like 90% of the week 4 syllabus. Like, listen carefully. This, I mean, like, make note of it. We only know the x coordinate. X coordinate. coordinate of the, what is this? It's coordinate of the district 3. Clear? If someone asks y coordinate, what is the y coordinate? You can follow the same thing, like 0. No, y coordinate is, look, this is the R1 curve. This is the R2 curve. When we draw these curves, like there is a intersection point between 11 and 13, which we found in this way, like by using f of x equal to g of x here. If y is equal to 0, y is 0, then it won't be a curve. It would be a line. Maybe right. Like you can go to the practice questions. For practicing more questions, you can go to the practice questions. If like, or else there is some book. Just I will share you the name of the book. Just wait. The book name is Introduction to Algebra. A real world approach. Ignacio below. Author is Ignacio below. Okay, we will close the session. Bye, guys.